In this online lecture, we are going to study about Friedel-Crafts acylation. Now, in this reaction, what we need to do is we need to react benzene ring, which is over here, with the acyl chloride, and then we place the acyl group on the benzene ring. This is how the reaction proceeds. So this is going to be your product of this acylation reaction. So if you can recall from the alkylation reaction, so we just substitute the alkyl group on the top of benzene. So this also follows electrophilic aromatic substitution. So it follows that mechanism, EAS mechanism. And what happens here? So if we go ahead and talk about this acyl chloride here, which will act as a Lewis base, okay, and it will react with AlCl3, the another reagent here, and since it is going to accept the electron pair, it will act as a Lewis acid, and this one is donating the electron pair. This will be acting as a Lewis base. So what will happen here? Chlorine will be attracted towards this aluminium metal. It will be forming AlCl4, and since it gained chlorine atom, it will have negative charge, and this here he lost chlorine, and it will gain the formal positive charge. So you just generated the electrophile here, and let's talk about this electrophile here, and then we will go into the mechanism of this reaction, which is over here. So if we talk about this electrophile, so RC double bond O, as you already know that oxygen carries two lone pairs. So resonance is possible here. This is what we want to show you. This lone pair of electrons can move here, okay, and what will be the result of that movement? So oxygen, since this lone pair moved here, forming the third bond with carbon, and then since it lost its electrons while doing so, it will gain a formal positive charge. Okay, so now you can see here, like in alkylation, there is no carbocation rearrangement. That is what I've written here. So as you can recall, in alkylation, carbocation rearrangement was happening. If you remember it, from the primary carbon, it went ahead and did a hydrate shift, and then it formed the secondary carbocation. So carbocation rearrangement was there. No such thing you need to worry about acylation reactions here. So this is one a bonus point for these kind of reactions. Now let's talk about this thing. Now we just generated the electrophile here. Now what this electrophile will do, let's go ahead and do the mechanism, how we reach here. So this benzene ring, as you already know, we have generated the electrophile. This pi bond will attack here on this carbocation, okay, which will do what? Which will introduce this RCO double bond O group. This is the acyl group. We call it acyl group here, okay. So that is why it is known as acylation. So this acyl group went ahead and attached here, right? And then what is happening here? So this introduced the plus charge on this carbon here. So there was a double bond. That double bond attacked here on this carbocation, right? Introducing a positive charge here. Since you already know what is going to happen here. So this hydrogen is gonna move. Okay. So I'll draw here. Just to give you an idea. So this base will go ahead and extract this hydrogen. Okay, so this hydrogen will be extracted by this base. Okay, and then what will happen? This double bond will move here. Okay, this double bond will move here. Let me draw it in some other way. So this double bond will move here. That's a better way of showing. So you have this double bond here. This hydrogen went ahead and reacted with base, and this is your acyl group attached on the benzene ring. So this is known as Friedel-Crafts acylation, when you introduce your acyl group on the benzene ring.